Okay, shall we start? Hypothesis test for population mean. I think that we have discussed that. Test for population mean. Right, first we discussed hypothesis test for population mean. Population mean. We won't discuss that. After that, difference. The idea behind this hypothesis test for population mean, this is your population. With regard to population mean, mean later, you have sums. Suppose that the value mu 0. Example mu 0 means 50, like that. 50. Like that. Assumption is that the numerical value is indicated mu 0. You select the sample. In the sample, you calculate X bar. X bar you calculate. Is there? Suppose that this value is 49.8 kilo average according to standard deviation. According to this value, can you accept your sums? You see 50 kilo. That's what hypothesis test for population mean. Okay. This value you want to test whether it is correct or wrong. Whether it is correct or wrong, you want to check. Now, if your size of the sample 30 or more, consider last. Then you apply the table. If the size of sample less than 30, small, you apply T table. I discuss size of the sample, large is more like that. When you use T table, degrees of freedom we want to use one sample. If it is degrees of freedom is given by n minus 1. That is the idea behind hypothesis test for population mean. This assumption you want to test whether it is correct or wrong. You have to accept or reject at the end. Right, that's what we want to do here. Right, first we write down the meaning of this. We have an assumption. We have an assumption about the population mean. About the population mean. About the population mean. Selecting a sample. Sample mean. Within bracket text bar. Selecting a sample mean. In bracket text bar. Is calculated. According to that sample mean, Our assumption is tested. Our assumption is tested. If the size of sample is, 30 or more, within bracket n greater than or equal 30. The size of sample 30 or more, that is the large sample. That is a large sample. Is a table is applied. Is a table is applied. Set table is applied. If the size of sample is less than 30, within bracket 10 less than 30. That's simple. The size of sample is less than 30. Bracket this one. That is a small sample. That is a small sample. T table is applied. Degrees of freedom is given by, write down this one, df equals n minus 1. Degrees of freedom is given by n minus 1. Right. The idea is this. We want to follow steps. When you use 5 steps, you can do hypothesis. Right? Hypothesis you can test. Then write down, use the following steps. Step 1, define null hypothesis. Define null hypothesis. H naught null hypothesis. Our assumption with regard to population mean mu, a particular value I can write mu c. 0 is a number. 50 kilo, like that. This is step 1. Define null hypothesis. Suppose a bag of cement, we expect 50 kilo. If it is mu 0, 50 kilo. Burning hours of electric bulb is 500. Mu 0, 500 hours. Height of a product is 2 meters. Mu 0 is 2 meters. That's one. Step 2. Define alternative hypothesis. To know how to define H, A, otherwise H1, both you can use. HA, alternative hypothesis. Mu not equal mu 0. This is a simple hypothesis. This is a composite hypothesis. Frequently null hypothesis is defined as a simple hypothesis. Alternative hypothesis is frequently defined as composite hypothesis. Simple means one value, composite means many values. We learn all this. isn't it? Not equal you can use, otherwise you can define HA like this. Mu less than mu0 you can define. Or you can define alternative hypothesis mu greater than mu0. At the time 1, but 3 ways you can write. One test, when you are doing only one test, you write this one, or this one, or this one. All the 3 we don't use at the same test. One of these 3 you select. Not equal means that is the two-tailed test. Two-tailed. Less than means that is lower tail. Lower tail. Greater than means upper tail. These two, one tail. At a time, we select what? From alternative hypothesis, you can identify where you are going to test both sides, two tail. Lower side only, lower tail. Upper side only, upper tail. Not equal means you can write this one equal. This is less than means if you need, you can define this one mu is less than, greater than or equal mu0 also you can write. This can be written mu less than or equal mu0 also you can write. But no need to use this. Why? Simple hypothesis we write for null hypothesis. From this you can identify two tail, lower tail, upper tail. Therefore, no need to write like. You write like this, null hypothesis also you can write as composite. Composite, many values. Okay? Right. Third part. Decide the level of confidence so significance. Decide the level of confidence so significance. And identify acceptance and rejection regions. Acceptance and rejection regions. Right. If it is not indicated, which one you use? 95% confidence. Right. Always we can use 95% confidence if it is not indicated. Otherwise, 99% or 90% also you can use. If it is not given, use 95% always. Therefore, within bracket write down. If it is not given, use 95% level of confidence. Use 95% level of confidence. Level of confidence. Right. According to 95% level of confidence from Z table, you know this is your confidence. Confidence means probability. Probability means confidence or significance. 95% when we use. Acceptance region, two tail. You know confidence, that is my acceptance region. Significance, rejection region. If I use 95% confidence, that is similar to 5% significance. I divide equally 0.475, 0.475, 95%. Because in estimation you learn that 5% means 0.025, 0.025. That is rejection region. When you take center point Z is to 0, what are the values of these critical values? 1.96 minus 1.96. That is 95%. Now I take this side. Lower tail test you want to do, same distribution, center point. Entire 5% you have to assign to lower side. Therefore 0.05 you apply here, not 0.025, because that is one tail test. Entire 0.5 50% here, if it is balanced, should be here. Out of 50%, 5% when you subtract, it will become 0.45. 0.45. Now you are having acceptance region, rejection region. Here 0.45 from Z table when you refer, it will become 1.65 lower side negative. Then upper tail this side. Entire 5% to upper side 0.05. Here 0.45 balance. Then you can see 50%, 50% here. Then acceptance region you can see here. Rejection region here. This is 0, 1.65 positive. Positive. This is two tail. This is lower tail. This is upper. According to the test, you want to decide acceptance and rejection region like this. Right? By this red color, I mark rejection regions. Two sides. One tail, this one. 50%, 50% both sides, but 5% when you assign, this will become 45%. When you refer Z table 45%, 0.45, you can see 1.65. Lower side negative, upper side positive. Right, that is acceptance and rejection region. Right, always the acceptance and rejection region you want to note down like this in your test. Any clarification, please ask. Two tail equally divided. One tail, assign that significance level to the test area. Lower side, assign fully 5%. Upper side, assign fully 5% to the upper side. According to your test, you need to decide acceptance and rejection regions. That is step 3. In the differences also, you have to do like this. In our next hypothesis, difference of population means. Right, confidence significance means a probability. Altogether 100. Then step 4. Step 4. Calculate test statistics. Calculate test statistics. Calculate test statistics. Yes. Calculate test statistics. How we calculate test statistic? Sample mean x bar minus expected mean mu 0 divided by standard error, standard deviation over square root of sample size. What sample standard deviation we want to use? Therefore, this formula PV x bar minus mu 0 over sample standard deviation divided by square root of sample size. That's the formula you want to use to calculate test statistics. This is standard sample standard deviation, because population standard deviation you cannot find frequently, right? Many sample standard deviation. N means size of the sample, x bar sample mean, mu 0 expected mean, which value you assume. S means sample standard deviation. N means sample size. X bar sample mean. Mu 0 expected value, that is my expected mean. Right, that is step 4. Final step. Last one. Step 5. Take the conclusion. Take the conclusion. Take the conclusion. Conclusion means if your test statistic, this calculated value belongs to acceptance region within this region, or from this to this side, or from this to this side, acceptance region. H naught is accepted. Mu 0 is correct. If test statistic belongs to rejection region, H naught is rejected. That is our conclusion, decision. Right now we write down, if test statistic belongs to, acceptance region, H naught is accepted. H naught is accepted. Acceptance region, H naught is accepted. If test statistic belongs to, rejection region, H naught is rejected. H naught is rejected. H naught reject means alternative hypothesis. HA you accept, right? H naught is rejected. What is meant by this? This means that sufficient evidence is there to reject H naught, right? Therefore, within bracket write down. This means that sufficient evidence is there. Sufficient evidence is there to reject H naught. To reject H naught. Sufficient evidence is there to reject H naught. That idea is H naught is rejected. Right, in this hypothesis, first I did null hypothesis, then alternative hypothesis, probability to decide the acceptance or rejection region, test statistic, and conclusion. The HFETC approach. Null hypothesis, alternative hypothesis, probability, test statistic, conclusion. By using these steps, you can test hypothesis HFETC approach. Right, therefore we write. This is called HFETC approach. This is called HFETC approach. HFETC method or HFETC approach. Null hypothesis, alternative, probability, test statistic, conclusion. Like that, practice your hypothesis. Okay, now we start the question number 1. It is expected that the average height of a product is 64 inches. 64 inches. With a sample size of 100 large, 30 or more large. 100 is tested. The average height is 67 inches with a standard deviation of 2.5 inches. Test the expectation using 95% confidence. Okay, then I start to define null hypothesis, alternative like that. First decide whether this is a two-tail or one-tail test. It is expected that average height of a product is 64. If it is 64, two-tail or one-tail. Average height of a product is 64. If it is 64, should be 64. Cannot be more than 64. Cannot be less than 64. Both sides you have correct. Therefore, you decide, I want to test as two-tail. The minimum height is 64. Upper side is not a problem. Which side is the problem? Lower side. Lower side should be controlled. Minimum 64, cannot be less than 64. Lower side. Problem area you want to test. Where the problem, that side you have to test. Right, now I define as a two-tail test. Null hypothesis. Null hypothesis H naught mu equals 64. Null hypothesis H naught mu equals 64. 64 is mu 0. Null hypothesis. Alternative hypothesis two-tail, therefore 64 not equals 64. That is step 2. Then take acceptance and rejection regions, large sample, therefore 95% confidence, 0.475, 0.475, 95% acceptance rate. 0.025, 0.025 rejection region. You know it's a table 1.96 minus 1.96, they are changed. Acceptance rejection region. So size of the sample 100, large, 30 or more is a table. Right, then we start to calculate test statistics. Test statistics. Sample mean, expected mean, standard error. When you test the sample size of 100, what is the average? 67. But the expectation 64. Then with the standard deviation 2.5. 2.5 standard deviation divided by size of the sample 100. Now calculate. 67, 64, 3. Square root of 110 divided by 2.5 is divided by 10, 0.25. Right, then 3 is 12, 0.25. Here, square root 10, 0.25, then 300 means 12. Test is statistic 12. Okay, change your interpretation, conclusion. Minus 1.96 plus 1.96, we accept H1. This belongs to outside rejection region. 1.96, 2, 3, 4, 5, 6, like that, 12, this side. Therefore, we reject this one. 64 is rejected. Why? In the sample 67 you obtain, that is not random or by chance. There may be a massive problem, or there may be a problem of the producer. Something there we cannot expect 64 as the weight of the product, as the height of it. In the sample 67 we obtain, that is not random. Normally it is not happening. Therefore 64, no, we can't accept, it is not 64. Alternative you have to accept because test statistic belongs to rejection region. H not reject means we accept this. That is our conclusion. There may be a problem. As in not is part.
We decide the belief is not rejected.
Yeah, conclusion. Test statistic 12 belongs to rejection region. Belongs to rejection region means this should be rejected. H now. When you are selecting 100 sample, 67 average with a particular standard deviation, this value is not random. Height, you expect 67, 64, but 67 cannot be accepted as 60. If this value belongs to acceptance region, you can say this is normally happening. When you take a bag of cement, one bag may be 50 kilogram, another one 50.2 kilogram, another one 49.8 kilogram. We can test, we can check whether that is random or not. Sometimes it may be exactly 50 kilogram we cannot take. It will change. But if it is random, your test statistics would be in acceptance stage. That's the way you can test any field, right? The business or the service sector or maybe health sector, you can test. This is the way. Right. Now we write down conclusion. Test statistic belongs to rejection region. Test statistic belongs to rejection region. H naught is rejected. H naught is rejected. H naught is rejected. This means that average height 64, average height 64 cannot be accepted, cannot be accepted. Right, that interpretation is finished, right? Within bracket, write down the idea further for your purpose. Within bracket, write down in the sample, average height 67. Average height 67 is not random or by chance. Is not random or by chance. Is not random or by chance. But that is for your purpose. No need to write in the interpretation. Even though you can write, no problem. Anyhow, take the decision whether H naught is accepted or rejected. Test statistic belongs to acceptance region, H naught accepted, rejection region, H naught is rejected. Even though your critical value, test statistic belongs to this critical point, 1.96, this value 1.96, we reject H naught, we reject H naught. Critical value එක ආවත් reject කරනවා H naught. Okay. When you calculate test statistic, you obtain 1.96. Exactly critical value. H naught reject. Right. So now we start question number 2. Question number 2. One businessman says that the average weight of his product is 20 kilogram. A sample size of 50 is selected. The average weight is 19 kilogram with a standard deviation of 5.3 kilogram. Test the statement using 95% confidence. 2 tail low, 1 tail. Average weight of his product is 20 kilogram. 2 tail. So both sides you can test. Large sample or small sample? Large. Then you use Z table or D table? Z table. Right. Now we start. Null hypothesis mu equals 20 kilogram. That is your expectation. As a two tail, if you define mu not equal 20 kilogram, then you use two tail 95% confidence because size of the sample 50. 0.475, 0.475 acceptance regions. 0 to 5, 0 to 5 rejection region. 1.96 minus 1.96. You have to understand very clear. That's why all the terms I discussed step by step. Estimation, as well as hypothesis test. Because we learn these, all these terms we learn. Therefore, no difficult. Now calculate test statistic. Sample mean, expected mean, standard error. In the sample 19 kilogram, but expectation 12. Standard deviation 5.3. Square root of the sample size 50. Right, now I calculate square root of 50. Minus 1.33. Minus 1.33, it belongs to acceptance features. Acceptance, isn't it? Therefore, in your conclusion, you can write test statistic of acceptance region H naught is acceptance. In the sample 19, you obtain average weight that is random. It is normally happening in the business. Right. Right. Then you write your conclusion. Conclusion. Test statistic belongs to acceptance region. Test statistic belongs to acceptance region. H naught is accepted. H naught is accepted. Right. 20 kilogram is correct. 19 is random. Normally happens. Right. Now practice question number 3. One newspaper says that at least 14 hours of internet per month are used by people in a selected area. A researcher has done a study to examine the usage of internet by people, selecting a sample size of 50, large sample. The average usage hours are 13 with a standard deviation of 3.5. Test the statement using 95% confidence. One newspaper says that at least 14 hours of internet per month. Two tail or one tail? One tail. If it is one tail, lower tail or upper tail? Lower tail. At least 14. Therefore, you want to test at least 14 means cannot be less than 14. Therefore, lower side to test. Otherwise, you are testing upper tail. After testing, you say, no, your statement, newspaper statement is wrong. People are using 17 hours. Can you take the receipt? That newspaper says at least 14. 17 hours, your statement is wrong. They are using 17 hours. The newspaper may say, that's why I mentioned at least 14. Isn't it? Therefore, lower side you have to test. අවමාසයෙන් පැය 14ක් භාවිතා කරනවා කියපු වෙලාවක උගල ටෙස්ට් කරලා කියනවා නෑනේ 14ක් නෙමෙයි මේ බාන්න 17ක් පාවිච්චි කරනවා. පිස්සුද කියලා. At least 14 අවමාසයෙන් 14ක් කියලා කිව්වේ ඒකයි. නේ? lower tail. Right. Test as lower tail. Null hypothesis H naught mu equals 14 hours. I want to test as lower tail mu less than 14. As this is less than 1, you can write greater than or equal this counts. But I write as a simple, therefore this is sufficient. Lower side, I want to test, therefore, entire 5% I take to that side, 0.0. 10.5, 0.45, acceptance region, rejection region. 0. 1.65 you can see when you refer is a table 0.45. Test statistic I calculate x bar minus mu 0 over standard. When 50 you examine 13 hours. That is answer mean, expectation 40, standard deviation 3.5 hours, size of the sample 50. Okay, now check. Minus 2.02. Minus 2.0. Problem. Yes. But that's the way you have to test hypothesis. Now interpret. I think you are familiar now. The interpretation, test statistic belongs to rejection region. Test statistic belongs to rejection region. H naught is rejected. H naught is rejected. The idea you know. H naught rejected means when you are testing 15 people, 13 hours with the particular standard deviation, that is not random. 14 hours you can't accept. They are using less than 14 hours. They are not using 14 hours. That's why. Here indicates 14 no more. But this is rejected means you accept this one. People are using less than 14. Isn't it? Right. Any clarification? If you need, please ask. This is the way always we check hypothesis.
The lower take that we have placed.
Yeah, because at least 14. At least 14. At least 14 means you want to check whether you have to go for the two tail. Both sides do you want to test? At least 14. But if the newspaper says 14 hours use, right? If it is 14, should be 14. Cannot be more than, cannot be less than 2 tail. At least 14 means upper side maybe 15, 16, 17, 18. At least 14 means there should be at least 14. Cannot be less than. Therefore, lower side. If a producer says that, or newspaper says that maximum hours 14, then minimum side, no problem. We want to test upper side. That's the way 2 tail or 1 tail practically you want to decide. That's why I mentioned electric bulb burning hours 500. 500 burning hours if electric bulb, do you want to test 2 tail or 1 tail? 1 tail. 1 tail, lower tail or upper tail? Where the problem? Bulb පැය 500ක් දැල්වෙනවා. Lower side, the upper side ප්‍රශ්නේ තියෙනවා. Lower side, lower tail. වැඩිුණාට ප්‍රශ්නයක් නැහැ. Isn't it? Electric bulb burning hours, you are expecting 500 hours. පැය 500ක් දැල්වෙන bulb එකක් ඔයගොල්ලෝ ගන්න යනවා. right? කියලා producer එක 500ක් දැල්වෙන bulb එකක් ඕන. එයා කියනවා 700ක් දැල්වෙනවා මේක. එහෙනම් මට එපා. එහෙම කිව්වා. Upper side is not a problem. Practically lower side. Likewise, you can decide 2 tail low, 1 tail practically. Empirically, you decide. Right. Now start next question. A chair producer says that his product can wear 150 kilogram. Affordable weight. තරන්න පුළුවන් බර පැයක 150. කිලෝග්‍රෑම් 150. Sample size of 64 large. Has an average weight of 145 kilograms with a standard deviation of 16.8 kilograms. Test the producer's statement at 5% level of significance. But sample 64, 5% significance means we know 95% confidence. कोई पैटर्न दूंगा गंड हो. Two tail low, one tail. One tail. This one tail, lower tail, low upper tail. Lower tail. Claim. Chair producer says that his product can weigh 150 kilograms. පුටුවට දරන්න පුළුවන් බර කිලෝ 150. If it is, upper side is not a problem. When you put 150 kilogram, no damage to the chair. Okay. 160 kilogram you put, no damage. That is good. Therefore, upper side is not a problem. When you put less than 150, there is a damage. There is inferior quality, low quality product. They have to reject that. Kilogram किसी पना बारह तियान न बोलने को तो उड़ी. ना इटा अडुएन तीनों के कैटेगरी पास है. मैं इटा वैल्यू किया कैटेगरी पुराने से आपने. Producer says that 150. आई किलोग्राम दे दिया थी. Right. Therefore, lower tail test you want to do. Right. As a lower tail test, you can start the calculation. If you are unable to decide whether it is lower tail or upper tail, you can decide right. This may be two tail. It's not mu equals 150 kilo. Mu less than 150. If the weight of the chair is 150 kilogram, yeah, you can use both sides. Two tail. පුටුවේ බර කිලෝ 150 දෙපැත්තම බලන්න. Two tail. වැඩි උනත් ප්‍රශ්නයක් අඩු උනත් ප්‍රශ්නයක්. Affordable weight to the chair is 150 kilogram. පුටුවට බලන්න පුළුවන් බර කිලෝ 150. If it is one side, you can test. Low tail. Okay, clear? උඩින් බර තියාගෙන ගිහලා කිලෝ 200 300 1000යි උඩින් අලියෙත් තියනවා කැඩෙන්නේ නැහැ ප්‍රශ්නයක් නැහැ නේද? Lower side is the problem. Right. If it is lower tail, I want to use the same thing here. Zero 0.5, 0.45 acceptance region, 0.05 rejection region, 1.65 minus. Know that. Test statistic, but sample 145 minus 120. Standard deviation 16.8. Tested how many items? 64. Right. I do 63.8 over the other person's minus 2.38. And 45 when you testing the sample, therefore 150 you can't accept. It's rejected. Less than 150. Right now you decide. Writing the weight. Test statistic belongs to rejection region. Rejection region. Test statistic belongs to rejection rate. Thank you. Test statistic belongs to rejection region. H naught is rejected. H naught is rejected. Right? Therefore, the producer's statement you can't accept. It is rejected. Right. Question number 5. It is expected that the maximum voltage used by an electronic device is 110 volt. When a sample size of 8 is selected, for example, the average use voltage is 115 volt with a standard deviation of 3 volt. Test the hypothesis at 5% level of significance. Two tail low, one tail. One tail. It is one tail, lower tail, upper tail. Upper tail. Upper tail. Maximum voltage used by an electronic device is 110 volt. Remember, voltage is higher. When you are testing, maximum 110 means lower side you don't want to test. Because even though you test and identify 50 volt, 10 volt, then you can't argue with the producer. He says maximum 110 volt. Therefore, upper side is the problem. Because that adu කොච්චරකට ප්‍රශ්නයක් නැහැ. 110 volt, 90 volt වැඩ කරනවා. Come on. 50, 20 voltage network වැඩ කරනවා. Come on. Cannot be more than 110. Right? Upper tail test. Right. Now do as the upper tail test. H naught mu 110 volt. Upper tail test I want to do greater than 110 volt. But because of last sample, let me on the Dandewal 0.05, 0.45, 0.5, acceptance region, rejection region, 0, here 1.65. Test statistic. The item you have tested 115 volt, 110 your assumption, but 3 volt standard deviation there. Size of the sample 80 items. Right, now check. $14.9. Point. Right, always write the interpretation. Test statistics belong to rejection rate. H naught is rejected. Right, question number 6. One electric bulb producer says that the burning hours of their product is 500 hours. When a sample size of 100 bulb is tested, the average burning hours is 495 hours with a standard deviation of 10. Test the producer this statement at 5% level of 6. 2 tail low, 1 tail. 1 tail. Lower tail low, upper tail. That is burning hours. Okay. 2 tail are the but Electric bulb burn in our upper side is not a problem. Lower tail is better, practical. But therefore, test as a lower tail test. H naught 500 hours. Alternative hypothesis less than 500 hours. Hundred bulb tested 495 hours. 495 but expected 500. Standard deviation there are 10 hours. And 1 minus 5. Minus 5 means H not rejected. Right? Test statistic belongs to rejection region. H not is rejected. H not rejected means H A you accept less than 500. Right. Question number 7. It is expected that the maximum weight of a product is 20 kilograms. But a sample size of 25 items is tested. Small sample. Average weight is 22 kilograms with the standard deviation of 4 kilograms. Test the expectation at 5% level of significance. Even though it is given 95% confidence, you know 5% significance. Is this two tail or one tail? Maximum weight of product is 20. One tail. Lower tail or upper tail? Maximum 20. Right. Small sample. You have to use T table. If it is T table, degrees of freedom is minus what? Calculation please. Right. Now we start. H naught mu equals 20 kilograms. This means that 20 or more. It's a maximum 20. Maximum 20 means this 20 or less. Alternative we write more than 20. Maximum 20. For a mistake. Now it's a very bad. 20. Now you are having upper tail is 0.05, 0.45, 0.5, acceptance region, rejection region. Set table, no problem, 0.45, 1.65. But here you use T table. Therefore, take degrees of freedom n minus 1. N means how many items? 25 items. 25 minus 1, 24 degrees of freedom. Two tail 0.025. But one tail, you have to use 0.05. Two tail 0.025. But here, one tail, T table 0.05. This is the significance area. T table is providing this area. Therefore, 0.05 you have to use. Two tail if you use 0.025, this side also 0.025. Therefore, you have to use two tail 0.025. One tail 0.05. That's why all these terms I discuss step by step. Okay. Last week, two tail, if you do, we know 0.475, 0.475 acceptance rate, 0.025, 0.025 rejection rate. The T table when we use degrees of freedom I need here 25 minus 1, 24, but only one sum. Here I want you 0.02%. Because two tail. One tail when you take 0.05. Therefore 0.05. Is a table 0.475. One tail 0.45. Okay? And you want to understand any clarification, please ask. Irrespective of the language, you have to ask, you have to understand. Clear, Nether?
25 minus.
Yeah, because degrees of freedom. So chalo naam ki kata karan. Degrees of freedom, one sample n minus 1. Two samples. Degrees of freedom n1 plus n2 minus 2. Sample එකයි නම් n minus 1 කිව්වා. Sample දෙකයි නම් n1 plus n2 minus 2. ඒ ලියන්න තියෙන්නේ නේ? කතා කරන්නේ degrees of freedom. ඒ කතා කරන කොයිලා? Estimation වලදී. estimate කිරීමේදී. Estimation මම කතා කළා නේද? ඔව් කතා කළා මතකයි. මට මතකයි. Estimation කතා කරා. සුචල නාමකය කියලා මම Monday Tuesday කියලා දාලා මම පෙන්වනවා වගේ මතකයි. මේක හැදෙන විදිහක් නේ. මකරේ ඇඳුම් පහ කරන මොකරි එකක් දාලා ඉන්නවා. හරි. තේරීම් අවස්ථාව කොච්චර number of values which are having free when restrictions are placed on data. කොච්චර අවස්ථා ගන්නක් තියෙනවද? තේරීම් සහිතව. Right? That is degrees of freedom. මම ඉස්සරහට කතා කරගෙන යනකොට ඕගොල්ලෝ පස්සේ කලින් ඉගෙන ගත්ත ඒවා ඩිලීට් කර කර එනවා. දැන් ගන්න එපා. Right, now identify using T table. 24 degrees of freedom, I take T table. 24 degrees of freedom, 0.05 I use. And two tail එකක් නම් මම භාවිත කරන්නේ මේක. One tail එකක් නම් 0.05 මේක. Right, 24 degrees වලට යනවා. 24 here. Then you can see 1.71. Two tail unana 2.064. One tail 1.71. 1.71. Then calculate test distance. අවබෝධ කරගන්න පොඩ්ඩක්. තේරුණාද යනවා. If you couldn't understand any place, please ask. I explained several times so that you can understand. Right. In the sample, average weight 22 with the standardization 4. 22 in the sample, expectation 20, standard deviation 4, size of the sample 25 items. 25 items. Right. 2.5. Rejected. Therefore, write the interpretation. Test statistic belongs to rejection region. H naught is rejected. Right. Question number 8. Management of a company says that their productivity is 30. Productivity of 10 days is provided below test statement. 10 days there. Productivity is 30. See height. ඔන්න upper side එක ප්‍රශ්නයක් නැහැ. Lower side එක විතර test කරලා පුළුවන්. Right? But test as a 2 productivity is 30. Minimum productivity is 30. You can test lower. Maximum upper side. But here productivity 30, therefore test as 2 20, 25, 32, 28, like that, 10 days. Smooth sound. Data provided. If data are provided, you know how to calculate mean and standard deviation of a sample. Descriptive statistics. We learn at the very beginning. Right. Now, mean and standard deviation, we want to calculate, use your scientific calculator and take mean and standard deviation. To know how to calculate mean, x bar, sigma x over n, and standard deviation I want to calculate sigma x minus x bar squared divided by n minus 1 square. This formula. It's so simple sigma, no problem. But using scientific calculators, directly take first take mean and standard deviation. What is your mean value? What is your standard deviation? Data provided. Twenty, 25, 33, 28, 30, times 25, 26, 25, 33. 38.5. When I take standard deviation, it's like 4.624. And you will calculate cut down. Over done the power, done. I discuss SD mode, SD mode. Or ES calculator, 1 minus variable option. Statistic mode, 1 minus variable option. SD mode in MS calculators. I didn't define how to hypothesis. Mu equals 30 productivity as a 2 tail not equal 30. Then I take acceptance and rejection region 0.025, 0.025, rejection regions 0.475, 0.475, acceptance region. Z table, if I use, I know 1.96 plus and minus, but I have used T table. A small sample, therefore n minus 1 degrees of freedom, 10 days data, 10 minus 1, 9 degrees of freedom. In the T table, 0.025 I want to record. Because here only 0.025. Now take 0.025 from T table. 9 degrees of freedom, 0.0, 2.26, 2.26. 2.262 plus 2.262 minus. Because of two tail. One tail, you use this value, 1.83. Right, now take decision, test the statistic. X bar 28.50, expected value 13, standard deviation 4.624, square root of the sample 10 days. That is your test statistics. Minus 1.02. It belongs to acceptance region. Right. Therefore, 28.5 you got from the sample. B. Is correct. This is factor. You are humbling with that. Right. Then you write test statistic belongs to acceptance region. H naught is accepted. Productive 30 correct, right? H naught is accepted. Actually, you government done right. H naught accepted means 30 is correct. Right, practice next question. A cement company says that the weight of their product is 50 kilograms. And a researcher selected a sample size of 10 to test this statement. A small sample. Weight of the sample item is provided by the following table. Test this statement 2, 4, 6, 8, 10. Right. Calculate similar X bar and standard deviation. Make it kind 10. Therefore, 2.262 is correct. Average weight 50. As a two tail, I am going to test. 9 degrees of freedom, again 0.025, 2.262, plus and minus. Test it. Right. I enter this data to obtain mean and standard deviation. Take mean and standard deviation. Right, any clarification? If you have, please ask. 50, 50.2, 49, 49.2, mang SD model 48.7. 50, 49, 51, 48, 51. $49.61 mean value. Correct? Then is 6. 0.991. Right. History statistic mean value 49.61, expected 50, standard deviation 0.991, square root of the sample size 10. What is the value? Minus? Minus 1.24. 244. Accept. The 49.61, these samples, it is normally happening. It is correct. Right. Still you interpret test statistic belongs to acceptance region. H naught is accepted. H naught is accepted. That is correct because in the sample you obtained 49.61 because amount of cash. Purposefully producer has not reduced. Or no problem in the operations. Normally happen. Right, this is the hypothesis test for population mean. Only one. But if sometime you have to test difference to companies, to industries, right? To countries, to areas, you want to compare whether there is the difference. Same product maybe two brands. You want to test how you can be. For that purpose, we want to go for the next hypothesis test. Right, now we take second hypothesis. Hypothesis test for difference of population means. At the beginning, we noted down what to test. What to test. Now we take second one. Hypothesis test for difference. Difference of population mean. Population means. We want to test. සංගහන මධ්‍යන දෙකක් අතර අන්තරේ පරීක්ෂා කරනවා. Various hypothesis test for difference of population mean. And before giving the note, first I explain like this. I want to explain that. Now suppose two population. Population 1, population 2. You assume that population mean mu1, second population mean mu2. You assume that no difference between these two. You assume mu1 equal mu2. No difference. They are equal. Quality is equal, brand is equal in the sales, whatever it is. Company equal, country is equal. Employees, male performance, female performance equal. Like no difference between married and unmarried with regard to the performance. Like this. Select sample. Sample 1, sample 2. No need equal. Here may be 30, here may be 50, no problem. You calculate sample mean x1 bar, x2 bar. Based on this difference, you are going to test your sums, whether there is a difference. Right? We assume that no difference. Using this difference, x1 bar minus x2 bar, we want to test our sums. If your sample size first one also 30 or more, second one also 30 or more, both should be satisfied, 30 or more. This body is people. Big, large. Applies. Otherwise, you have to use T table. Otherwise means this may be 40, this may be 20. This one. Both may be small or one may be small. You have to use T table. Otherwise, the small, apply T table. T table, when you apply two samples, they are 0.1 plus N2 minus 2 degrees of freedom. Right? Degrees of freedom, two samples you add, subtract 2. This is the way we are testing hypothesis difference of population means. මේකත් තියට හෝ වැඩි මේකත් තියට හෝ වැඩි. මේක 20ක් වෙලා මේක 50ක් වුණත් වැඩක් නැහැ. Small. Both should be more than 30 to apply it. Even though one sample is small, you have to apply a T table. Okay, right. This is the idea. First we write down like this. We assume that there is not a difference. Between two population means. Between two population means. Within bracket, mu1 equal mu2. Even though you are taking this one as mu1 minus mu2 equals 0, say. When you take this mu2 left, minus mu2 equals 0. Right? Both way are right? mu1 equal mu2. Selecting two samples. Difference of sample means this one x1 bar minus x2 bar. Difference of sample means x1 bar minus x2 bar is calculated. Based on that difference, assumption is tested. If both samples are large, in bracket write down N1 greater than or equal 30 and deducted N2 greater than or equal 30. If both samples are large, apply Z table. Otherwise, use the T table. With degrees of freedom. Otherwise, use the T table with degrees of freedom given by right? DF equals N1 plus N2 minus N1 plus N2 minus degrees of freedom. Right. Practically, you can test these assumptions with regard to male, female, married, unmarried, and higher education and lower education, to countries, to industries. Check, right? Right? Therefore, only one sentence write down. As an example, we can test assumptions. We can test assumptions between male, female, comma, married, unmarried, two products, two countries, two companies, etc. Right. Compare කරන්න පුළුවන් මේක. එතකොට එක sample එකක් test කරනකොට whatever we discuss first one to this one. Later I take more than 2, 3, 4, 5, 6 all these one way and over. One way and later I discuss. Tasman kata කරනවා. Later means before the end of this program I discuss. Okay. After correlation regression, you obtain correlation regression handout. Correlation regression handout එක හම්බුණා නේද? හම්බලා තියෙනවා. I sent here. It may be in your LMS. Right? You can check. Because next handout, correlation regression. After that, one way alone. Okay, this is the way we want to do. Again, we want to follow 5 steps. Right? Then we write down, use the following steps. Use the following steps. Correlation regression handout එක ඇවිල්ලා නැද්ද? Right. Step 1. Define null hypothesis. Define null hypothesis. How you define null hypothesis? Mu1 equal mu2. You can write. Otherwise, as I mentioned, mu1 minus mu2 equals 0. No problem. The meaning of this, in wording also you can write. Finally, what come out? No difference between the two population means. Population means අතර වෙනසක් නැහැ. One of these you can write. This is null hypothesis. Step 2. Define alternative hypothesis. Define alternative hypothesis. Define alternative hypothesis. HA can write mu1 not equal mu2. And frequently as a two tail, if you use, you can find. But if you need, you can write mu1 less than mu2 also you can write. Or you can write mu1 greater than mu2. No problem. As the two tail you can do. As lower tail. Or this as one tail. This means that there is a difference between the two population means. There is a difference. There is a difference. Or not less, higher, like that you can write. There is a difference. Right. Step 3. Decide the level of confidence or significance. Decide the level of confidence or significance. And identify acceptance and rejection regions. Acceptance and rejection regions. Decide the level of confidence or significance and identify acceptance and rejection regions. That is similar. Two tail 1.96 minus 1.96. Acceptance region, rejection region. When I use 95% confidence. Lower tail 1.65 minus rejection region, acceptance region. Only they are unchanged. Upper tail 1.65 rejection region, acceptance region. You know here 0.475, 0.475. Here 0.025, 0.025. One tail test 0.05, 0.45, 0.5. Here 0.5, 0.45, 0.05. Have an Australian? Right, then step 4. Calculate test statistic. Calculate test statistic. Right, when you calculate test statistics, right? Large sample, one formula. Large sample. Right. Test statistic x1 bar minus x2 bar divided by s1 squared over n1 plus s2 squared over n2 square root. That is large sample. Sample is standard deviation first one, second one. Size of the sample 1 and 2. First sample B, second sample B. Okay. You can apply like this. Large sample. Right then, small sample. Right, a small sample like this. In estimation also we did this. Right, a small sample. Test statistic equals x1 bar minus x2 bar divided by approximate standard deviations. We calculated the estimation. Multiplied by square root 1 over n1 plus 1 over n2. SP we want to calculate. N1 minus 1 S1 square plus N2 minus 1 S2 square divided by N1 plus N2 minus 2 overall degrees of freedom square. That is test statistic in small term. This is SP means approximate standard deviation. Approximate and deviation. In estimations also we use this SP as it is. Okay. The last step. Take the conclusion. Take the conclusion. Conclusion means test statistic acceptance region is not accepted, rejection region rejected. Right. Now we write. If test statistic belongs to acceptance region, H naught is accepted. H naught is accepted. If it belongs to rejection region, H naught is rejected. H naught is rejected. Right, now start question number 10. Ministry of Education says that there is not any difference between the students of schools A and B. When a sample size of 50 from each school large is selected, the average mark of students in the A school is 80 and the B school is 75. With regard to the marks you are going to test the difference between these two schools. The standard deviations are 10 and 8 marks respectively. Test the statement of the ministry at 95% level of confidence. Ministry of Education says that there is not any difference between the students of school A and B. Right, now I am going to define hypothesis. H naught U A school O1, right? UB marks. Otherwise, no difference between the two schools. In relation to marks. Notation we write. Alternative hypothesis I am going to test as a two-tail UB. Then how many you have selected? There is our 50-50 large. The opposite table you can apply. 0.475, 0.475, acceptance region. 1.96 minus 1.96. Rejection regions 0.025, 0.025. Now you are familiar. Then test statistic x1 bar minus x2 bar. S1 squared over n1 plus S2 squared over n2 squared. Sometimes you can see a simple sigma 1 squared, simple sigma 2 squared, same formula. Right? Because that is standard deviation of population we can't take. Practically we have to use sum. Right, then marks 80, A school, B school 75. 80 minus 75. Standard deviations 10 and 8. 10 square, size of the sample 15. 8 square, size of the sample 15. Now test the statistics, decide your conclusion. Two point 76. Because what I have then. Then take decision. It belongs to rejection region. Therefore, it's not reject. There is a difference. ඒකෝ සමාන නැහැ. 80 marks 75 කියන එක ස්කූල් දෙක අතර හරි වෙනසක් තියෙනවා. Now we write test statistic belongs to rejection region. Test statistic belongs to rejection region. H naught is rejected. H naught is rejected. උත්තරයක ප්‍රමාණවත් නම් වරහන් එක ලියා ගන්නවා within bracket write down there is the difference between the two schools. There is a difference between the two schools. There is a difference between the two schools in relation to marks. In relation to marks. Marks will turn on in subjects. As to why the target become applicant in subject. Right now, practice next question. If the size of selected samples of the above schools is 10 and 15 respectively, test the statement of the ministry again. Normally, when the sample size is changed, mean standard deviation, they will be changed. But for our understanding, suppose that all the others are unchanged, sample size 10 and 15, we change. Then what happens? A small sample. Right, test as a small sample. I want to use T table, therefore I want to change my critical values. Question number 11. Null tail alternative but by persons taking the silence. According to degrees of freedom, N1 plus N2 minus 2. Size of the sample 10 and 15. 10 plus 15 minus 2 and 3 degrees of freedom. At 0.025, why we use 0.025? 210. A table is providing one side, 0.025 from T table. 0.025, 10, 15 means 25, 23 degrees of freedom, then 2.069. 2.069. And here 2.069 minus 2.069. Okay. Then calculate test statistic. First, I want to take approximate standard deviation first sample size 10 minus 1. What is the standard deviation? 10 and 8, after 10 square. Second sample size 15, 15 minus 1. What is the standard deviation? 8. Yeah. 10 plus 15 minus 2 at 20 degrees of freedom. This is approximate standard deviation. 9 plus 64. 8.836. You can check whether this calculation is correct. How? This value should be between the two standard deviations, 10 and 8. ආසන්න කරපු සම්මත අපගමනයේ සම්මත අපගමන දෙක අතර window 10 and 8. 8.836. Cannot be more than the highest, cannot be less than the lowest. අඩුවකට අඩු වෙන්නත් බෑ, වැඩි එකට වැඩි වෙන්නත් බෑ. Should be in between. 8.836 is between 10 and 8. Right, then using this, you can calculate your test statistic, this formula. I write that here. X1 bar. Mark 75, right? 850 minus 75. Approximate standard deviation 8.836. Multiplied by inside the square root 1 over first sample size 10 plus 1 over second sample size 50. $1.386. It belongs to acceptance table. Calculate කරලා බලන්න practice කරන්න. $1.386. Correct? Right. Then write interpretation. මේ තත්ත්වයක් කරතේ නම් ආවේ data test statistic belongs to acceptance region. Test statistic belongs to acceptance region. H naught is accepted. No difference between the two schools. H naught is accepted. Right here, write only one question, then the next two can practice later at home. Two companies produce same product by using different process. Their productivities have been provided below. Test whether there is a significant difference between the two productivities. Product 1, product 2. Productivities. We have obtained data 2, 4, 6, 8, 10. Right. Product 1, product 2, data provided, mean value you have to calculate. Mean product 1, mean standard deviation, product 2, mean standard deviation. Right, ini දෙකේ ඉක්මනින් calculate කරලා ගමු. X1 bar, X2 bar, S1, S2. Fifty, 52, 51, 49, 48, 52, 47, 49. Times and 20. $49.7. $1.636. Right, second sample. 53, 47, 49. $49.3. $1.946. Okay, these values. The values को देंगे. Tahu nih, mata awak pasti tahu. Today. Right, now two companies produce same product. Our hypothesis mu1 equal mu2. Right, quickly we calculate mu1 not equal mu2. Acceptance and rejection regions 0.475, 0.475, acceptance region 0.35, 0.025, rejection regions. But use degrees of freedom in 1 plus 10 2 minus 2, 10 plus 10 minus 2, 18 degrees of freedom. 18. Aku gonna recommend speed calculator 18 degrees of freedom. 2.101. 2.101. Right, to calculate test statistic, I want to use X1 bar minus X2 bar, approximate standard deviation 1 over 1 plus 1 over 2. Approximate standard deviation for sample 10 minus 1, its standard deviation 1.636 square. Second 10 minus 1, 1.946 square divided by 10 plus 10 minus 2 square root. That is approximate standard deviation. $1.797. Just in between. Then I calculate here 49.7 minus 49.3 divided by approximate standard deviation 1.797 square root 1 over 10 plus 1 over 10. $0.497. Take the decision. Test statistic belongs to acceptance region. H naught is accepted. Therefore, no difference. Right. Similarly, practice this question at home. 13th question. Right. As a homework, do it. Question number 2. Practice karo right track with that. Even though you are at hostel, that is homework. Hostel again here, hostel no capture. Okay, you sign. Sign. Okay, correlation and regression handout I will check.